Hello, everyone. We are back with another honors geometry lesson. This time it is on the quadrilaterals, trapezoids, and kites. So, a trapezoid is a quadrilateral with exactly one pair of parallel sides. So that's the definition of a trapezoid. So, we have some properties of non-isosceles and also of isosceles trapezoids. So, non-isosceles trapezoids only have one pair. I could put the number one, it's probably easier to read. Only one pair of opposite sides that are parallel. And the consecutive angles between parallel lines are supplementary. So that would be like, for example, this 90-degree angle and that 90-degree angle would be supplementary. So that's just an example. And then we have isosceles trapezoids. They have all of the same properties that we saw up here, plus the non-parallel sides, which are known as the legs, are congruent. That also means that these base angles are also congruent. And then therefore, the opposite angles are going to be supplementary. All right, so we'll use that information to help us solve some of these problems down here. All right, so we want to find the measure of angle K and the measure of angle M. So to find the measure of angle K, I look here. That is going to be supplementary with angle L. So I do 180 minus 51 to get 129 degrees. And then the measure of angle M is going to be supplementary with angle J. So I do 180 minus 87 to get 93 degrees. Okay. And then when I look at number 2, same idea, except now this is an isosceles trapezoid. So we know that the base angles are congruent. So that means the measure of angle W also has to be 47 degrees. And then the opposite angles are supplementary. So that's going to be 180 minus 47, which gives us 133 for both of these, since they also have to be congruent to each other. Okay. Next one, we want to solve for x here. Oh, that's my spot. Okay. So I see that they are on the same side, so I know that that means that they're supplementary. So to create my equation for that, I have 54 plus 8x plus 6 equals 180. So 8x plus 60 equals 180. 8x equals 120. If I subtract 60 from both sides, divide both sides by 8, that leaves me with x equals 15. And that's all I wanted in that one. I wanted to solve for x. Okay, this one kind of similar, except since I know that this is an isosceles trapezoid, these two angles are going to be congruent. So that's how I'm going to start my equation by setting. See that? I turned my computer off. Setting those equal to each other. Let me make this. Oh, I can. So I have 2x plus 27 equals 5x minus 12. So to solve this, I'll bring my x's to the right, my constants to the left. That's 39 So I know the measure of angle, or I'm sorry, the measure of x, value of x, Friday, is 13. And I want to find the measure of angle A. So that's opposite from angle C. So first I have to find the measure of angle C. So that'll be 5 times 13 minus 12, which is 53 degrees. So then the measure of angle A, 52 would be better. Yeah, measure of angle A is 180 minus 53, because those are supplementary. And then that's 127 degrees. Okay. Fun stuff to do. And same idea here with another isosceles trapezoid. So if this is an isosceles trapezoid, find the measure of each missing angle. So those will be congruent, these will be congruent, and then those are going to be supplementary. So my first equation that I'm going to do is add these two angles together, set it equal to 180. So I have 10x plus 5 plus 6x minus 1 equals 180. I'll combine like terms. Now I will subtract 4 on both sides. So I have 16x equals 176. Divide both sides by 16. X equals 11. So then if I were to substitute that in, so the measure of angle Y is going to be 6 times 11 minus 1, 66 minus 1, 65 degrees. So this angle is 65 degrees, so that means that angle is also 65 degrees. I can find the value of W in two ways. I can either substitute that in, or I can subtract from 180. So I'll just substitute in. That's 10 times 11 plus 5. I know that I should get, what, 120, 115? What's math? 180 minus 65. Yeah, 115. So that's 110 plus 5 is 115. Good. So then these two angles are 115. All right, so the measure of angle W, 115 degrees. Measure of angle X, also 115. Y and Z are both 65 degrees. Okay. Keep it moving. One more. When we have side lengths this time. So let's label them. We know that we have an isosceles trapezoid. So we know, let's label what we have. Okay, so I have MP is 16x minus 13, NO 9x plus 8, PN, so that's this diagonal, 5y plus 19, and MO is the other diagonal, 12y minus 37. Solve for x and y. So in this situation, we don't have a system of equations to solve. I know that these two legs are going to be congruent and that the two diagonals are also congruent. So I'm just setting those equal to each other. 16x minus 13 equals 9x plus 8. And 5y plus 19 equals 12y minus 37. All right, so I solve this, get my x's to the left, Beyonce style. And that gives me 7x equals 21. So x equals 3. And then my y's to the right. That gives me 56. Divide both sides by 7. And we get 8. So my solution, x equals 3, because that's what I'm looking for. Solve for x and y. Y equals 8. So those are the basic properties of a trapezoid. And then also the mid-segment of a trapezoid has some pretty cool properties too. So let's talk about them. The mid-segment of a trapezoid connects the midpoints of the legs. So I know that E is the midpoint of segment AD because of these tick marks here. Likewise, F is a midpoint of segment BC because of these tick marks, making segment EF a mid-segment. So if segment EF is the midsegment of this trapezoid ABCD, then I know these things to be true. I know that segment AB is parallel to segment CD, which is also parallel to segment EF. So these are all parallel to each other. And then I can also find the measure of segment EF. So the measure of segment EF is going to be the average of the two bases. So I add those together and divide by 2. Okay. So like if that was 4 and this was 6, the midsegment would be 5. All right, so here we go. If the measure, I'm using this trapezoid up here to answer these two questions. So if AB, the measure of AB is 14, and DC is 26, find the measure of EF. So I'm just plugging that into this formula that we already used here. So that's 40 divided by 2, which is 20. That makes sense because that's halfway between 14 and 26, making it the average. All right, here, if the measure of EF is 22, we want to find AB, and we know DC is 38, we can just work backwards from that. So I multiply both sides by 2. 44 is AB plus 38. Subtract 38 from both sides, and we get AB equals 6. 6 units. So that's 16 away from 22, and 22 is also 16 away from 38. Okay, here we go. Another one. For this trapezoid, now we're incorporating algebra into it. Y and Z are midpoints. So that means YZ is the mid-segment of the trapezoid. So I'm setting this up the same way I did this numerically. So I know that 5x minus 19 is the average. So that's 38 plus x plus 14 divided by 2. So I'm going to multiply 2 times 5 minus 19, set that equal to x plus 52. So I have 10x minus 38 equals x plus 52. So I have my x's on the left, 9x. Bring my constants to the right equals 90. So now I know that x equals 10. However, I want to find the length of segment YZ. So I can get that from substituting the value of x in. So that's 50 minus 19, which is 31. So if this is 31, That's 7 away, so another 7 away from 31, 24. That makes sense because 10 plus 14 is 24. We love logic. We love when it just works out. All right, another one similar, except we have expressions for all three segments. So we'll just do it the same way. The mid segment equals the average of both bases, x plus 7 plus 6x plus 5 divided by 2. So multiplying both sides by the 2, I'll save that step here. 16x minus 6 equals, combine my like terms in that numerator. So that's 7x plus 12. So I'll get, subtract 7x on both sides, 9x, add 6 to both sides, that's 18, leaving me with the value of x being 2. Now I want to find zy, the length of segment zy. So that's 6 times 2 plus 5, which is 12 plus, did I make a mistake? Did I mess something up? Zy. I didn't. I'm feeling good. Sorry for the alarm. So that's 17. And then we could just check to make sure that makes sense. If x is 2, that would have to be 9. It's 8 away, 4 away, this should be 13. 2 times 8, 16, minus 3 is 13. Perfect. All right, so that's trapezoids. All the Fetty Wap fans. And now let's look at kites. We'll fly a kite, one of the few things you can do right now at the beach, etc. So properties of kites. It literally looks like a kite, so that's nice that it is real. Okay, so a kite is a quadrilateral with the following properties. Exactly 2 pairs of consecutive congruent sides. So that's these 2 sides right here. And these 2 sides right here. Has to happen. 1 pair of opposite angles are congruent. So that's these angles are congruent. And the diagonals are perpendicular. So all of that makes for a beautiful kite. All right. So let's go fly a kite up to the heavens. So if each quadrilateral below is a kite, find the missing values. So looking at this kite here, these 2 angles have to be the congruent angles. So the way that we'll figure out what that is I'll do 360, the total degrees in a quadrilateral, minus 85 plus 43. See what that gives us. So that gives me 232. So that's how many degrees I have between these 2 angles. So I just have to split that in half, and that gives me 116. So each of those angles is going to be 116. All right, next one. Fun. So we know that the diagonals are perpendicular, so that gives us a little triangle. So what we can do with that is figure out the measure of this little missing angle. So 90 minus 59 is 31. So this little angle here is going to be 31 degrees. Just like that little angle there is going to be 31 degrees since these 2 total angles are congruent. So I know that this is also 59 degrees. Okay. So I'm checking to see, so that's all I can kind of figure out from this. So now let's see what angles we are looking for. So the measure of angle GDE. GDE. So that's this whole angle here. So if I just added 59 and 59, that would give me 118. And the measure of angle DEH. DEH, 31, we found that already. DGH, we found that already. Look at us. Who would have thought? Look at us. All right, keeping it moving, keeping it going. Looks like this will also have be similar. Not mathematically similar, but as they say. Okay. What can I do here? So angle 4 first, that has to be a right angle, which is 90 degrees. Here, that 46-degree angle is going to be the same as angle 1. And that 73-degree angle has to be congruent to angle 5. So from here, we're just looking at triangles and subtracting. So I'll do 2 and 3 are going to have to be congruent. That'll be 90 minus 46, which gives us 44 degrees for angles 2 and 3. And then 6 and 7, I'm going to do 90 minus 73 to get 17 degrees for 6 and 7. It's like a little puzzle. So satisfying. All right. Next one. Let's label what we're given because our figure is not labeled at all. So if the measure of segment AC is 38, I'm going to go ahead and split that up to a 19 and 19. And the measure of segment ED is 41. Find the measure of CD. Perhaps upon first glance you think, not enough information. I say nay. We know that is a right angle. Thus, we can use Pythagorean theorem. So we know a squared plus b squared equals c squared. We can just substitute those values in. So 19 squared plus 41 squared equals, we can call that x for now. So when I sum the squares, I get 2042. And then to solve for x, I take the square root. Those eliminate. And I can round to the nearest tenth, 45.2 is the length of CD. Cool, huh? All right, 2 more. Hang in there. All right, let's find these angle measures. We want to find the measure of angle FGJ. So let's see where that FGJ. So that's this angle. So I imagine in order to do that, we know that this is a right angle, and we'll have to do 90 minus whatever that is. And these have to be congruent to each other. So let's set them equal, shall we? 5x minus 1 equals 2x plus 11. X is to the left, constants to the right, x equals 4. Cool, so I can get the measure of angle JFG. That's this angle here. So that's 2 times 4 plus 11, which is 19 degrees. And then the measure of angle that I want to find, FGJ, is going to be the complement of 19. So 90 minus 19, 71 degrees. Okay, and then finally, we want to find the measure of angle NQP. NQP, so that's this whole angle there. So let's see what we know first. We have this angle and this angle. What I already know is that this, okay, well, I want it to look like 2 marks. This can go into this. And then those two have to be complementary. So why don't I add those two expressions together, set them equal to 90, and solve for x. 11x minus 23 plus 4x minus 7 equals 19. Combine like terms on the left. 15x minus 30 equals 90. 15x equals 120. So x has to equal 8. All right, and then I keep saying all right. I'm sorry, that's so annoying. So now I want to know what the measure of angle NQP is. So that's just twice that angle. So the measure of angle NQP is 2 times 4 times 8 minus 7. So that's 2 times 32 minus 7, which is 25. So that's 50 degrees. I had fun. I hope you had fun. Learned a little something. So yeah, try your homework. Reach out if you have any questions. Have a great day. Bye.